linear models, we're going to do them 3 different ways. All right, for this first way, it's kind of more just a review. You probably won't see a whole lot of problems like this on test or something, but it is something still good to know that you did, I think, I don't even know when, 7th, 8th, 9th, who knows. It's where you're given a word problem, and we are going to put it in the form of mx plus b, where b is my starting point or my base value of something. And m is going to be your rate, something you multiply by something, or it's happening every time, something along those lines. Right? So you're given this word problem. Allen, Texas has an elevation of 120 feet above sea level. A hot air balloon taking off from Allen rises 40 feet per minute. Write an equation to model the balloon's elevation as a function of time in minutes. Predict the height of the balloon in 10 minutes. So, for my linear model, y, which is the elevation, what is my rate going to be?
40.
40. Is it going to be a positive 40 or a negative 40?
Positive.
Why positive?
Rising.
Very good, because you're rising. So positive 40 times t, because t is minutes, right? Every minute you're rising 40 feet. And where am I starting at?
120.
Positive 120? Why positive?
Because above sea level.
Very good, because above sea level. All right, so that's my linear model. And then the second part of this equation is the prediction part. It says predict the height after 10 minutes. So where am I plugging 10 in?
T.
Into the t, because it's time.
Yeah.
All right, so what is 40 times 10? 400 plus 120?
520.
520. So it will be 520 feet above sea level.
I love this. I did not. I'm so tired of this.
All right. I believe this next part is also something that you have done before in the calculator, but we're going to refresh your memory, and you will be using this in this class multiple times. All right? It's called linear regression. And we're not just going to have linear regression in this class. We're going to have quadratic regression and exponential regression and all different kinds of regression, because we have all these different kinds of functions. But for this unit, we're just doing linear regression. So I don't want you, unless you're really good at multitasking, I would prefer you watch me do this and write the steps down. And then the second example, I will let you do yourself. All right? So for right now, though, just watch me do this. And then you can work out the second example yourself. So on your calculator, the first thing is you're going to go to the home screen right here. So first step, go to the home screen. And you're going to click New Document. You're going to go to the home screen, you're going to click New Document. Probably when you do this, you're going to have something that says, do you want to save the unsaved document, unless the person cleared it out before you. Just click no, because you don't need to save it. All right, so you're going to get to this screen where you have all of these options here. So home, new document, don't save if that button pops up until you get all these options. And because we have these list of values, we are going to do list and spreadsheets. So we're going to click the button that says List and Spreadsheets. That one right there. And so you get all of these columns here. And then we are going to put all of our values in. Alright, so I'm going to put 5.6 in, 3.5 in, 2.4 in, 8, 5, 3. Oh yeah, down here. So I'm going to put all my values in. I'm going to put this in one column, this in another column. And most people can get to this point, and then this is kind of where they might get confused. You have to tell your calculator what you're doing, because your calculator doesn't know. As of right now, you just put some numbers in these boxes, and that is all your calculator knows. So you need to go up here and label your columns. Oh, geez. All right. You need to go up here and label your columns. So you have to say, this first column is my population. The second column are my representatives. You can label them P and R. You can label them X and Y. It doesn't matter. I normally do X and Y just because it works for everything and for the steps. So I'm going to label A, X, and label B, Y. Alright, so watch me do this step because this is where people get confused. You need to go up here where A is highlighted, and then you're going to type X in, and then you can scroll down, and you're going to go over here where B is highlighted, and you're going to type Y in. If you leave it so it's white and the cursor is here and still blinking, your calculator is not going to like you, and it will not do it. So if you go to menu, you see how they're all gray? It's not going to let you. It doesn't like that because you haven't actually labeled it yet. You have to arrow down or enter or something and say, yes, I'm labeling that Y. Because if the cursor is there and it's white, you haven't finished. Does that make sense?
Yeah.
Okay, so make sure that it's not white anymore and you label it up here X and up here Y. And then we're going to go to menu. We're going to go to statistics. We're going to do stat calculations. Menu, statistics, stat calculations, and it gives us all of our types of regression. And because my problem says to create a linear model, I'm going to choose linear regression. I'm going to pick the MX plus B because that's the form I'm most familiar with. It's the form I like and the form I can graph. So then I'm going to do lin reg. I'm going to pick the MX plus B one because that's the form I'm in. And then this pops up. Once again, you have to tell your calculator what are your X values and what are your Y values. Because just because you labeled that one column X and that one column Y, it's not labeling those are my X, those are my Y. You're saying this, you're just naming your columns. So this is the part where it's saying, okay, my X values are going to be the numbers in column X, and my Y values are going to be the numbers in column Y. Now, something you cannot do is just type a Y in. Okay? You have to use your drop-down menu. Okay, so if you arrow to the right, do you see how it drops down? Because these are the options that you have. This is what you labeled your columns. So if you labeled your columns P and R, a P and R would pop up. But since I labeled my columns X and Y pop up. What's up?
So when the X looks, whenever you click on the X, what does it have to do?
I don't know. It just does. I don't know what that means. All right, so for the X list, we're going to go, yeah, I don't know what that apostrophe is for. It's, I don't know.
It's in front of the Y too, it's just right.
Yeah. I don't
Yeah,
know what they're for. But I know that if you try to come in here and you just delete it and you type Y in, your calculator doesn't like that. You have to do the drop-down menu and pick from your options. Right? And so once you pick from your options, so that's going to be step 7. So X list, I normally just do the X. Y list, I do the Y. But make sure you do it from your drop-down options. And then you click enter and you get all of your possible values. And so to write the linear model, it tells you what your M is and it tells you what your B is. Right here. So for the linear model here, 1.544, because that's your M. times X or P or whatever you want to do. I'm going to use X because it uses X right here. So 1.544X. And then because this is negative, we'll do minus 0.588. And that's my linear model. Does that make sense? Okay. For the prediction, it says predict the number of representatives if you have 8.3 million people. So where am I going to plug in 8.3? For X, very good. So 1.544 times 8.3 minus 0.588. All right, so if you want this button right here, this guy right here, will let you go back to the calculate screen. This one right here. And so you can type in 1.544 parentheses 8.3 minus 0.588. And I'm going to round because people you can't have like 0.2 of a person. So it's still one person though. Like I wouldn't say someone who lost a leg, you're only 0.8 of a person. Can you survive if you don't have a lower half? You can? Like if you're waist down?
Yeah. There's a lot of people like that.
A waist? Like from your waist?
Yeah,
like,
they got no legs, so nothing.
And they walk on their hands.
Yeah, they walk with their
Huh.
hands.
But like, where does everything go?
They have a bag.
Oh.
No, they throw it up.
Yeah, you be quiet.
Anyways, I feel like that'd be really demeaning telling them that they're half of a person. So I would still count them as whole of a person.
You didn't know that? Oh my god.
I didn't realize you could survive if like, I mean I know people didn't have legs, but
They don't got nothing. They
like
just,
all of
right
that
here.
stuff, I thought that was pretty crucial to live on. Yeah. All right, flip it over. I'm going to do number 4, and then I will let y'all practice. So flip it over on number 4. You're going to go back and do it. All right, number 4. Focus back up
If
here.
only that worked like that.
So on number 4, we are going to be combining the last two things we did. I give you this word problem, and you are going to have to come up with the data points. So the smallest adult shoe size is a size 5 and fits a 9-inch long foot. An 11-inch long foot takes a size 11. Bob Lanier, who once played in the NBA, has a 14-inch long foot. Find the linear model to represent the situation and use the model to determine the shoe size. So I'm going to create my own table here.
Yeah, we love a good table.
Yep. And this one is a little confusing, I think. Not all of them are maybe this confusing with determining what is X and what is Y, right? But what is going to determine, how do I say this, does the shoe size depend on the size of your foot, or does the size of your foot depend on your shoe size?
Depends on your foot size.
Yes.
The shoe size depends on the size of your foot.
If I put a baby shoe on you, is your foot gonna magically be a baby size?
No, it's the shoes.
Wait, this is where you're supposed to sleep for longer than an hour.
The shoe size is based off the foot.
Right. So this is your foot size, and that is going to tell you what your shoe size is. So tell me one of my data points. What number is going to go here?
No,
Wait,
9. And right here? 5. And then what's the other one? 11, 11. Okay.
This is annoying. I don't like this problem.
All right, real fast. Okay, so if you are right here because you used your screen and you want to go back up but not do all of the work again, if you go back to home and you go to My Documents and you go to Unsaved, it'll bring you back to what you were working on. All right, so I'll do it one more time. If you're here and you go to home, go to my documents, unsaved, and it'll bring you back to what you were working on. And then also, if you want to, all right, you don't have to do it. You can start all over and, new document, don't save it, start all over. But if you want to, you can just change your number values. And do you see how the M and the B are changing? So you don't have to do everything all over again. Okay? But you have to delete all this other stuff.
Oh no.
And so make sure you just have those 2 points in. And then it'll give you your equation. So you don't have to do all the steps again if you don't want to. All right. So my equation here to determine my shoe size, this is an S, is going to be what? How would I write that? Yeah. 3. You can put X or L. I'm just going to put an L because that's what's in my problem here. I'm okay with X though. Minus 22. And then for my prediction, I want to know if he's got a 14-inch long foot, what shoe size is he going to have? So,
3 times 14.
yep. And you get 20. So he would have a shoe size of 20.